This is Unit 5 Test Corrections. For Part A, it is asking us identify which of the vectors above represents the net force exerted on the sphere at the moment shown, and just right. And I said right here is that no, it's A, which A is the horizontal of the force of the string, which is tension, because I said that the vertical string tension, vertical component of tension is cancelled out by mg, and so that I got 2 out of 2 points for this. For part B, it says, is the magnitude of the tension in the string greater than, less than, or equal to the weight of the sphere? Part B, I said the magnitude of the tension of the string is greater than the weight of the sphere, because the y doesn't change, which means the mg and the tension, the vertical, cancels out, but then it still changes its horizontal direction, which means the magnitude if the magnitude is greater, because it just still changes the horizontal component. The horizontal component is still there, and so for this, I got 3 out of 3 for this, because I earned a point for stating that it's greater than. I explained for the components of the vectors, and I also explained how they're sort of horizontal. Part C is asking us the string can never be completely horizontal no matter how fast the plasma is rotating without any equations or formula explain why. So for this, I got 0 out of 2 because I didn't use physics to answer this. I just said it was the platform spinning, so it can never be horizontal. But if you use physics, so the force of the string is T, and then there's a Tx and a Ty, and so since it is asking us if it can never be completely horizontal, which means there could only be there has to only be a x. There can't be any y, which is impossible because T is made up of both x and y, which I didn't really say that. So for this, I got 0 out of 2. Part D is indicate which expression is consistent with part C and explain why. So I said that it was equation 1 is consistent. Oh, but for this I got 1 out of 3 for this, because the requirements I didn't explain correctly, because it says 1 point is earned for I got the point for correctly indicating a flaw in equation 2, because it said that equation 2 is incorrect because L times cosine can never be equal to 0, because if you put 0 into theta, sine theta will equal 0, and you can't divide by 0, which means it can't be this one, so it has to be this. And I said that it was equation 1 because L times sine can't be equal to 0, which means the velocity is indefinite, but that's the wrong explanation, because the equation before, or not the equation, the part before, in part C, it says it can never be horizontal, in which I said it has to be perpendicular to be completely horizontal, so it can't be completely horizontal. So that's why the equation just makes sense because if you plug in 0, this will equal to 1, so, and this will equal 0, but you actually get an actual value. It's just equal to 0 instead of 1 over 0, which is not a value. So I got 1 out of 3 for that. I got 3 out of 3 for part E because it was asking us in series of experimental trials, a group of students changes L and just V to keep data constant. They record L and V based on equation find the indicator to yield slope to find the acceleration due to gravity. So the points says for the points is given for identifying Y on one of the axes. So I said or identify V on one of the axes. So I put V squared on the Y axis. And I put it over L, which is the second point. So V over L. And the relationship is V squared versus L, which I did say was V squared over here. And I said over L, and the slope would equal to is cut off as something caused by gravity. So I got 3 out of 3 for this. Part F is going to let I be the rotational inertia of the sphere. Platform is about a vertical axis about center. Does I increase, decrease, or stay the same when L increase? So L, I believe, is the radius or the length, and so if the length increases, and the angle stays constant, I said since when L increases but the data stays constant, the rotational inertia I would increase because I is equal to mr squared, in which the theta doesn't affect it, but the radius or L does. And since L increases, so does the moment of inertia. Because the farther apart it is, the farther the mass is distributed, the greater the rotational inertia is. Farther mass is distributed from the center. And so for part F, I got 1 point for identifying the rotational inertia will increase, and I got another point for stating that the mass is further from the axis, and so the rotational inertia is bigger. I got 2 out of 2 for this.